All right, hey everybody. So we're going to take and look at trying to pull all this together. So we've been talking about energy, and if you remember the first part of this packet, we looked at if I gave you a compound, how you'd figure out the energy for that compound by looking at the bonds and looking at that bond enthalpy chart. Remember that chart that we had that looks something like this? So we could figure out the energy for the compound. We also did a section where you looked at trying to figure out the balanced chemical equation. So we're going to use both of those things to help us to figure out what is the energy total for the reaction, and is it an endothermic or exothermic reaction? Okay, so first thing we're going to do is let's go ahead and balance the equation. So if you look up here, we're going to try to balance this. Okay, remember balancing means you need to have the same number of atoms of each thing on each side. So right now, if you look, you have 2 hydrogens on the left side, 2 hydrogens on the right side. We have 2 oxygens, but we have 3 oxygens on this side. Okay, so a couple things you can do. One of the things is we could balance the oxygens first. So we really need 1 more oxygen on this side, so I can put a 2 out front of this. Now that gives me 2 oxygens there and 2 oxygens there, so I have a total of 4 oxygens. So those are balanced, those are balanced there, and if we put a 2 here, that'll balance it. So now we have 4 hydrogens, 4 hydrogens, 4 oxygens, and 4 oxygens. Okay, so it's balanced. Okay, so when we look at a chemical equation, remember we have what we call the reactants on the left side and the products on the right side. Okay, and remember the reactants are breaking bonds and the products are making bonds. So if you look here, on the left side we have H2O2. That is the substance on the reactant side. So what we're going to do is we're going to try to figure out what is the total energy for the reactant compounds. Okay, and we have the drawing here, and if you remember what we do then is we look at, okay, what are the bonds, right? So the bonds that we have here are H to O. Okay, there's 1 here and 1 here, and then there's also an O to O bond. Okay, so if we look then, how many total of each of these do we have? So to H to O, all right, if you look up here, the H to O, we have a total of 2, okay, 1, 2 of those bonds, all right, but I have 2 of those, so I actually have a total of 4 H to O bonds, right, because I have 1, 2 bonds here, but I have 2 of them, so I have 2 H to O bonds, and I also have 2 O to O bonds, all right, or we have 2 of those. Okay, so I'm taking that back actually. I don't have just 2, I have 4, right? I have 4 of those. I have 4 of these, right? Because I have 2 here plus 2, all right? So I have 2 of those and then I have 2 of those, all right? So I have 4 H to O bonds and I have 2 H to O to O bonds. All right. So now what we need to do is figure out what is the energy involved there. All right. So we look here. If you look, okay, I have 4 of my H to O bonds. So H to O is right here. Okay. It is a total of 467 for the energy, 467 kilojoules. Okay, and we'll just leave it as kilojoules. It's really kilojoules per mole or kilojoules per molecule, but we'll just leave it as kilojoules for now. Okay, and if you look at the O to O bonds, O to O bonds is right here, 146. So we have 2 146 kilojoules there. Okay, so what I'm going to do is I will take my calculator. I'll show you what this looks like. Okay, I don't know how well we can see that, but we're going to take 4 times 467. So we get 1,868. And then we'll take 2 times 146. We get 292. We're going to add those 2 together and get a total. So we're going to get 292 plus 1 0.86 So 2160 kilojoules on this side. Okay, whoops. Okay, then we're going to repeat the same thing on the other side. All right, so we have a H to O bond here. Okay, so we have an H to O bond. All right, and I have an O to O bond, but you notice that's a double bond. We can put our dots there. Remember, the dots don't really mean anything for this in this scenario. Okay, so if I look, right, I have two H2Os, so that means I have two, and I have two bonds there, so I actually have four HO bonds. All right, and I have just one O to O bond. I'm going to add those two together. Okay, you have two of these bonds and you have two of them, so it's going to be a total of four. Okay, and then we already know from the previous problem that my H to O bond is a 467 kilojoules, and my O to O bond, which I need to look up, is a double bond right here, 495. 495. Okay. So this ends up being 1868 kilojoules. All right, kilojoules over here just to make it consistent. Okay, and then this 1 times 495. All right, so we're going to get 1868 plus 495. And that's going to give me 2363 kilojoules. Okay, so this number, whoops, kicking this table here, my number for breaking bonds is lower than my number for making bonds, right? So this is greater. This number is greater. Okay, so I already know I'm going to have it. It should be an exothermic reaction, because remember, the making bond side is exothermic. Okay, this is exo, and this is endo. Okay, but the way that we actually do it when we calculate it is we do broken, when we do our calculation, energy, if I can spell energy, minus formed. Okay, so we're going to do broken, which is 2160, minus formed, 2363. Okay, if we look there, that number is going to be 2160 minus 2363. So we got negative 203. Okay, so our number there is negative 203. Okay, when you have a negative number, that tells you it is an exothermic reaction. Okay, a positive number tells you that is an endothermic. All right, so when we went through kind of the steps here, we had to balance the chemical equations. We figured out how many bonds I had of each one. Okay, got the energy from the bond enthalpy tables, got a total for both sides. Okay, and then it's broken energy minus formed, and we ended up with a negative answer. And so we know that the negative answers will give you a exothermic reaction. All right, so hopefully that helps. See ya.